Welcome again, Wildcats. All right, so today we're looking at Friday, September 20th, and we're going to be doing square root transformations on page 45. So if you would, pause your video and update your table of contents. All right, now that your table of contents are updated, let's take a look at our notes. All right, so these should look very familiar because transformations, they work the same no matter what function. Now, you notice before we had either parentheses or absolute value here, but in this case we have square root. So the same rules apply. All right. So if you have the negative outside of the square root, it reflects over the x-axis. If the number in front of the square root is greater than 1, it's a vertical stretch. And if the number is between 0 and 1, meaning a fraction, meaning a fraction, it's a vertical compression. Now, the negative in front of the b inside the square root would mean that it reflects over the y-axis. And when the b is between 0 and 1, it's a horizontal stretch. And when b is greater than 1, it's a horizontal compression. So if you would probably pause a moment to write those down. And let's look at the next one. So then if you add h, it's a translation left. And if you subtract h, it's a translation right. And then last, if you add the k value, it's translated up. And if you subtract k, it translates down. So I'm going to kind of just move back and let you copy those down. So you might pause, update this part of the notes. And pause and update those. All right. So now that your notes are updated, let's take a look at the examples. All right. So example number 1. Now, example number 1 is the parent function. Okay. So we know that when x is 0, w of 0 is 0. When x is 1, you get 1. And so we can make a table x w of x. So 0, 0. And you can even, if you want to see what's going on, that equals 0. X is 1. The square root of 1 equals 1. We're going to skip 2 and 3. And I want you to pause and think about why would I skip 2 and 3. All right, so I'm hoping that you see that we're going to go to 4 because the square root of 4 is 2. And then we're going to skip for the same reason that the square root of 5 doesn't work evenly. Square root of 6, 7, 8. So we're going to go to 9. So the square root of 9 equals 3. So 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, 3, 4, 2, and then 5, 6, 7, 8, 9, 1, 2, 3. So this is the square root parent function. There is no transformation because it's the parent function. And the domain, remember, domain is from left to right. So it starts at left, and it's only greater than. So x is greater than or equal to 0. And the range is from bottom to top of the y. So it starts at 0 and it's greater, so then it's y greater than or equal to 0. Now the important part to notice here is that square root function is always going to have these directions, 1, 1, 4, 2, 9, 3. Okay, so we're going to use this to graph our transformation. All right, so let me wait a second, let you pause and update that. All right, example 2. Move this over a little bit. All right, so we're going to graph using the directions. So all you have to do is move the vertex, and once you do that, you know the directions are always going to be 1, 1, 4, 2, 9, 3. So we look here. So we're subtracting 1, so we know we move to the right 1 and up 2. This is our new vertex, which we'll call HK. From that, we know that directions are always going to be to the right 1, up 1, to the right 4, up 2, to the right 9, up 3. But we have to take into account for the negative 3. So we're going to multiply these values by negative 3. So really, we go to the right 1 down 3, 1, 2, 3. We go to the right 4, 1, 2, 3, 4, down 6. So 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. And then here we go to the right 9, down negative 9. So to the right 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, we're using the direction. All right, so the transformation. So let's start with the negative. We know it, well, actually, I like this. I'm going to do this last. I like these are easiest to do first. So this is subtract 1, so we know right 1 unit, up 2 units. I'm just going to write up 2. I would put units, but because of space, I want to be able to get all of them across here. And then reflect x-axis. And then it's a vertical stretch by 3 units. All right, so domain. So our x value is greater than 1, or greater than or equal to 1. And our range is y less than or equal to 2. So if you would pause a minute to update example 2. All right. Let's look at example 3. Use a description to write the square root function g based on the parent function f of x equals the square root of x. It says f is reflected across the x-axis, compressed vertically by a factor of 1/5, and translated down 4 units. So what I'd like you to do is pause the video, and I want you to try to write the function with these transformations. All right. So I'm assuming that you've paused. Now you've played. You're going to see if you did it correctly. So the first things first is if it's reflected across the x-axis, there's a negative in front of the square root. Compressed vertically means the 1/5 is in front of the square root. Oh, what was that? Oh, sorry, that's just the bell. All right. So then it's translated down. So the square root of x, nothing's happening under the square root. Down is minus 4. Make sure when you're doing this that you don't extend the square root too far to the right, because if you do, then it looks like that's under the square root. All right. So what I'd like to do is pause the video, and then I want you to try example 4 and 5, and then I'll explain those in class on Friday. All right, let's look at example 6. We're going to graph the square root inequality using transformations. So remember, whenever we graph, use the directions. So we first need to move vertex. So here we plus 4, so we go left 4 units, 1, 2, 3, 4. There's our new, so we know that's HK. So then, now we do directions. Now, we know there's nothing out here, so we just know we go to the right 1, up 1. We go to the right 4, up 2. And then we go to the right 9, up 3. And I always double check and count again just to make sure they're right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to be careful. I want you to ask yourself, well, is this a solid line or a dashed line? All right, I'm hoping you said there was a dashed line because there's no equal sign. And this is the mistake I always make is I forget to check. I just draw a line, but it's a dashed line. All right, now you have to be careful. When shading, you ask yourself, well, which direction do we shade? Well, I'm hoping you pause the video and reflected and that you shaded above the line. But you have to be careful. Nothing can go past this line. Okay, so you shade, but you shade above here and to the right. Now, I'm going to be looking for this in notes, but I want you to write why that is. Why we don't shade on the left here, but we start there. Okay, and I want you to write your explanation right there of why we do not shade to the left of this line. All right, so with that, I want you to try example number 7 for class and be ready with that and have a very patriotic Wildcat day.